Hello, my name is Felipe Gavilan, and in this video, we're going to see some of the new features of C# 11 for .NET 7. We're going to be using .NET 7 Release Candidate 1 and also Visual Studio 2022 preview version. So let me create a new project. I'll create a console application. Next, I'll say demo C# 11 eng .NET 7 preview and create. Alright, so let's get started. The first feature that we're going to see is raw string literals. Basically, this new literal allows us to have more control over a multi-line string. We don't have to use escape sequences to have special characters on those strings. Let's see that. We're going to say example 1, raw string literals. So in order to use raw string literals, we do the following. We're going to say variable raw string literal, and we have to use at least 3 double quotes and at least 3 double quotes to finish the raw string literal. So let me put a semicolon here, and inside of here I can put a multi-line string. As you can see here, we have this vertical line which indicates us what is the beginning of the string, the first column of the string. So for example, I can write here, hello, my name is Felipe, and I can press enter and go to the second line of the string, and again you can see this vertical line here which indicates the first column of the string. So the second line is going to start at the first column. So for example, I can say nice to meet you, and then if I want to start after the first column, I can press spacebar, for example twice, and then say this line is indented. So now let me say console write line, let's say write line, raw string literal, Control F5 to run our application, and we're going to see that indeed we have our string like this. Hello is in the first column, nice to meet you, likewise, but the third line starts with an extra space at the beginning. As I mentioned before, something cool about raw string literals is that you don't have to use escape sequences to have special characters in them. For example, let's say that I want to have double quotes here. I can do that, and there is no need for any special escape sequences. As you can see, I have meet here with double quotes, and I can use 2 double quotes if I want to, and there is no problem with that again. But if I want to use 3 double quotes here, then I have a problem. I have a problem because, as you know, this marks the start of the raw string literal, and then this marks the end of the raw string literal. So what I can do is to use 4 double quotes here and 4 double quotes here. So let me remove this extra double quote from here, which was added automatically by Visual Studio, and now as you can see, I don't have any errors. I don't have any errors because I have the flexibility to indicate how many double quotes initiate my raw string literal. So in this case it is 4. And why did I do 4? Because I need 3 here. And now as you can see, if I press Ctrl F5, you can see that I have 3 double quotes here. And again, if I need 4 double quotes, then I do 5 double quotes here, and so on. Another thing that I can do is to use a string interpolation in raw string literals. For example, let's say that I want my name in a variable, so name equal to Felipe, and then I want to substitute this, so I can use, as always, I can do this, and then use a string interpolation like this. I can put a C# expression here, and as you may know, this will substitute my name, the name variable, with its value. That is fine. But what happens if I want to have my name inside of curly brackets like this? Then I can do this, but as you can see, we have an error here. So how do we fix this issue? Well, what I can do is to say here $, so that now, in order to have a C# expression, I need to use 2 curly brackets. Now if I press Ctrl F5, you can see that this still works, but we're not getting what we want. What we want is to have this value inside of curly brackets. So now that I have the rule that having 2 curly brackets mean that we want to have a C# expression, then now we can use an extra curly bracket, because since this one is only 1, then they are treated as strings. So the idea here is that I can indicate how many curly brackets initiate a C# expression by using as many $signs here. So let's press Ctrl F5 and we're going to see that indeed we have my name inside of curly brackets. So let me close this and let me tell you that there are some rules in order to use rostring literals. The first one, of course, is to have the same number of double quotes at the beginning and at the end. So if I say here 5 double quotes, then this doesn't work. Of course, that makes sense. Another rule that you have to keep in mind is that this marks the end of the raw string literal, but also it marks the first column of the string. Now, you can have your string start after that first column. There is no problem with that. If I run my application, you can see that now I have a small space here. That is fine, but what you can't have is to have a line that starts before that column. So if I do this, I have an error. I have an error because if we draw a vertical line from here, we're going to see that we are missing out a character from our string. So bottom line is that you have to start at the very least from here. Now this is cool because if I do this and I press tap, 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 you can see that indeed, since this is moving, then this vertical line is also moving. Alright, so now let's see another feature of C#11. Example 2, we're going to see that we can have several lines in string interpolation. So let's do the following. Let's come down here and we're going to see that inside of an expression in a string interpolation, we're going to have several lines. For example, let's say that I have a variable here, temperature, let's say 24, and let me say string message equal to string interpolation, human sensation to temperature, temperature is, and then here in this second C# expression, we're going to use a multi-line C# expression. For example, I can use a switch expression. Let me say temp switch, and then here I can do the following and close here. And now let me put here my expression. For example, I will say greater than 45 degrees Celsius. This, we're going to have this result, greater than 35, too hot. And just so you don't have to see me typing all of this, I'll just copy and paste it. So as you can see, we have these values. So now the new thing is that, as you can see, we have a multi-line C# expression inside of an expression in a string interpolation. So now I can say console write line, and I can say message, and you're going to see that everything works. As you can see here, we have human sensation to temperature 24 is cold. Alright, so now we're going to see the third and final new C# feature for strings. So let me say here, example 3, UTF-8 string literals. Now we can create strings encoded with UTF-8 in a simple manner using the U8 suffix. So let's see what we had before. Before C#11, we had to do the following. We had to say UTF before C#11 equal to encoding. If I wanted to have a UTF-8 encoding, I have to say UTF-8 get bytes, and then, for example, hello. Now, in C#11, this is simplified by the following. UTF in C#11, hello, U8 suffix. And it is basically the same. This one returns a byte array, and this one is a read-only span, but it is basically the same. I can do a to array here, just in case you want a byte array. But anyway, the idea here is that we have this new suffix here. Now let's move on from string examples, and now let's see something else. We're going to start with list patterns. As you may know, we can use pattern matching in C#, and now in C#11 we can use pattern matching with lists. For example, let's say that we have the following array, 1, 2, and 3. Now I can see if this array follows some specific patterns. For example, let me say pattern 1, numbers is 1, 2, and 3. The answer to this is true because this has the same shape as this. Okay, now let's see another one. Numbers is 1 and 2. The answer here is false because this array have 3 elements and this one only have 2. Alright, but let's see something more interesting. Pattern 3, numbers is 1, 2, and discard. Now this means that we're asking the following question. Has this array the following properties? The first element is 1, the second element is 2, and I don't care what the third element is as long as there is a third element in the array. And the answer is yes, because here we have a 3, but we could have a 4 or a 5, it doesn't matter, because as long as it is an array of length 3 and that it has the first element as 1 and the second element as 2, then there is no problem. We can do another pattern, pattern 4. Here we can use relational expressions. For example, numbers is 1 and 2, and let's say greater than 2. Now here we are asking for an array that has the first element as 1, the second element as 2, and the third element as any number that is bigger than 2. Now let's see all of this on the screen. So for that I want to create a small utility method, which is this one, which will allow me to get an array and convert it to a string. It doesn't matter what this does, this is just for visualizing the array in the console. So let me say here, var numbers string equal to array to a string, and we're going to pass numbers, and now I will write several messages in the console. And as you can see, we have our array and then the pattern that we're testing and then the result. So let me press Ctrl F5 to run our application, and we can see the following. We can see that indeed this array follows the following pattern, that is true. This array does not follow this pattern because the length is different, so false. This array follows this pattern because it is an array of 3 elements and the third element can be any number, so true. And finally, this array follows this pattern because the third element is greater than 2. So that means that, for example, if I come here and instead of 3 I say 0, for example, then Ctrl F5 and we're going to get the following result. We're going to get that now this one doesn't follow this pattern because the third element should be 3, not 0, so false. Same here, it doesn't follow the pattern because the length is different. It follows this pattern because remember that the third number can be any number, but it doesn't follow this pattern because the third element should be greater than 2 and this is 0. So as you can see, we can use list patterns to determine in a quick manner if an array that we have follows a pattern. Now let's see the next feature, which is require members. Now we can mark fields and properties as required so that we can guarantee that they are initialized. Let's see an example. Let me come here, let me create a new class, add class. It will be a simple person class. And in here, let's see the following. Let me put here a property string name, and then I will have 2 constructors, and this one is going to receive a name parameter, and we're going to initialize the name property with this parameter. Okay, this is great. So now, if we go back to our program class, let me comment this out by the way, and also comment this out, this message from the second example, and let me say here example 5 required members. This is the name of the feature, require members. Now let me say here, let me see what we have. We can do person1 equal to new person, and there is no problem with this. I can do person2 equal to new person using the other constructor. I can say Felipe, semicolon here, var person3 equal to new person. I can also do it like this and say here name Felipe. This is all fine, but what if I want to guarantee that the name property is always initialized? Because here, as you may imagine, we don't have a value for name, so I want this to not be able to compile. So for that we can use a require member. So I can say here required, and now if I come back here, you are going to see that indeed we have a compilation error here because we must initialize the name property. This is great, so I can comment this out. But why do we have an error here? I mean, if we go here, we can see that we are indeed initializing the name property. Well, that is because C# doesn't know that, so it needs some help. So for that, we can use a attribute here, which is called sets require members, which basically indicates that this constructor indeed initializes all of the required members of this class. And now if we go back here, you can see that indeed we don't have any errors here anymore. The next feature is a new access modifier which is called file. The idea of this new access modifier is that it allows you to limit the scope of a type to a specific file. Let's see an example. If we go to the Solution Explorer, we're going to see that here we have two files, the person file and the program file. So if I go to the person file and I create a new class here and I use the file access modifier, let me say class person utilities, and let's say here public int get value 42. Then now we can only use this class from here, from this file. For example, I can come here and I can create a new method. Let's say public int get value. This is in the person class, of course. And let me say here var person utilities equal to new person utilities return person utilities get value. So as you can see, we can indeed use this class from here, but I cannot copy this and come here and say example file scope. I cannot do the following. I cannot say var person utilities equal to new person utilities. I cannot do this because I am in a different file here. It doesn't matter that I am in the same project. What matters is that I am not in the same file and therefore I don't have access to this person utilities class. So let me comment this out and let's continue. The next feature that we're going to see is auto default structs. The idea is the following. Before, in the past, when we had a struct, we were obligated to initialize all of its properties. But now that is not the case. Let's see that. Let's go to the Solution Explorer, right click here, add class, let's say point, and let me make it a struct. And now let's see that if I come here and do the following, I can have a parameterless constructor, and then I can have several properties, for example, x and y. And as you can see, there is no problem with this. We can compile our application just fine. Before, in C#10, this wouldn't have compiled. For example, let me come here and let me target .NET 6 so that we are using C#10 by default. You are going to see that now this doesn't compile. And this doesn't compile because we're obligated to manually initialize all of these properties. So for example, I have to do this. I have to say here int x control dot initialize, and then int y control dot initialize, and then now it compiles. But now in C#11 we don't have to do that. So let's go back to .NET 7, let's save, let me come here, let me delete this and this and this, and you can see that we can indeed compile our application. So this is example 7 auto default structs. Another new feature is extended nameof scope, which means that now we can use nameof in attributes. Let's first see what is nameof, just in case some of you don't know what nameof is. Example 8, extended nameof scope. Basically, nameof allows us to get as a string the name of a variable. For example, let me say here console write line name of, and let me say, for example, person2, which is one of the variables that we had before. So now in the console, this is going to write person2, Control F5, and let's see that we have indeed person2. So it is the name of the variable itself. So now what is new in C#11 is that we can use nameof in an attribute that is being applied to a method, and we can get from the attribute the name of a parameter of the method. Let's see that. Let's come here, let me make a new class here, which is going to be an attribute, a really simple attribute. Let me paste this. So as you can see, we have this simple attribute which inherits from attribute, and we have this parameter here. Okay, so what's new is that now I can come, for example, to the person class. Let me go to the person class and let me create a really simple method, as you can see here. And now if I use my attribute, I can say here, let's say that I want to pass the name of this parameter. I can use nameof now, my parameter. And that is great. And see that if I rename this parameter, we're also going to get that rename here, which is great. Speaking of attributes, we can use now generic attributes. This is cool. For example, if you want to pass a generic parameter to your attribute. For example, let's come here and let me say here t, and let me say here t generic value, and then here let me create this and let me say t generic value, and now let me say here generic value equal to generic value. Okay, so now I can do the following. I can say here, for example, a string, and then I can pass a second value here, which is going to be a string. But now I can do the following. I can say, instead of a string, I can say int here, and let me put a 2 here, and then I can pass a number here, like 42. And as you can see, we are reusing my attribute, but also we are using generics in it, so that we have more flexibility on what parameters we pass to the attribute. And finally, something else that we can do is that we can use generic math. This means that we can use mathematical operations on generic parameters of methods. Let's see that. Let's see an example of that. Let me come here and let me create a new class, public class. I'll call it generic math, and this is going to have the following method: public static tResult. We're going to make a sum method, which is going to have generic parameters. tResult. We're going to receive here an enumerable of t. These are going to be the values, so we want to be able to add several values, and I need to add some restrictions. I need to come here and say where t is of type iNumber base of t. This iNumber base basically allows me to represent numbers. So let me say here where tResult is also of type iNumber base tResult. So now I basically indicated that we can make mathematical operations with these parameters. For example, because I want to add the values of this enumerable, I want to have a 0 value so that I can do 0 plus the first value and then the result of that plus the second value and so on. So first I need the 0 value, and let me say here then tResult equal to tResult.0. Then we're going to do a for each value in values, and then we're going to say result, and we're going to add that to tResult create checked value. This create checked allows me to create an instance that we can use of this value, and then we're going to return the result, and that's it. With this, I have been able to create a generic algorithm that is going to allow me to add an enumerable of values. So let's see that. Let's use this sum method. Let's go to the program class and let's come here. This should be example 9, I believe. Generic math. Okay. So let's come here and let's do the following. Let me say in array int numbers, and I'll say 1, 2, and 3. And let me show you something. Let me show you that this int indeed has that 0 property or 0 field here, which is the one that we're using here in the person class. This 0, it actually exists. So now let's come here and let me do the same but for complex numbers. Let me say complex array complex numbers, and then let me say new complex 2 and 3, and then new complex 4 and 1. It doesn't matter if you don't know what a complex number is. It is basically a number which has a real part and an imaginary part. So in order to sum them, we have to sum their respective parts. For example, 2 plus 4 is 6, and then 3 plus 1 is 4. And let me show you that. We can come here and we can see that we have this 0 here, which is the one that we use again here, in here. So now let's come here and let's do our example. I want to say var result int numbers equal to generic math.sum int. I say that we're going to pass ints and we're going to receive an int as a result. So now we can pass the int numbers, and then we can do the same but for complex numbers. So result complex numbers equal to generic math sum complex, and then we're going to pass our array of complex numbers. And now we can write the result in the console. So we have this. Alright, so let's press Ctrl F5 to run our application and see that indeed we have the sum of 1, 2, and 3 is 6, and the sum of these two complex numbers is 6 and 4. 6 for the real part and 4 for the imaginary part. So as you can see, there are many features that C# 11 brings to us. If you want to learn more about .NET, like Entity Framework Core, building React and .NET applications, and also building Angular and .NET applications, please buy one of my Udemy courses today. Link with a discount in the description of this video. Thank you.